Problem number 2233, maximum product after k increments. Okay, you are given an array of non-negative integers nums and an integer k. In one operation, you may choose any element from nums and increment it by 1. Return the maximum product of nums after at most k operations. Since the answer may be very large, return it modulo 10 with the power of 9 plus 7. Note that you should maximize the product before taking the modulo. Okay, so it's non-negative integers. Can it have 0? Okay, it can have 0. So in each operation, you can choose any element and increase by 1. And return the maximum product of nums after at most k operations. So for having the maximum product, we should maximize each element well, it's at most k operations, so you don't have to do, but I think the best way will be use k operations will be better. Okay, if we have this, and the length of nums will be at least 1. So you can, if you can only have like 6, and then k is and k is like maybe 10, then so you will have 6 plus 10, then it's 16. So okay, for the example, like 6 3 3 2, it has a k equals 2. Okay, we want to get the maximum product. Is it like if we have maybe 8 multiplied by 3 2 is better, or there are many kind of ways, or like 7 4 I think like making everyone in closer will be better. Yeah, like if we add this 2 to 3, then it would be like the product of this will be 3 times larger. Will be 3 times larger than the before is 2 times. Okay, so let's maybe take the minimum. Yeah, every time we choose the minimum element and add it by 1 and return its products. Yeah, I think that would be nice. Okay, so we'll have let's create a heap, like a min heap, so that every time we know the minimum number, and we can increase the minimum number by 1 till the k is 0, and then calculate its product. Can k be 0? No. Okay, so we won't. But maybe we'll like there will be like 0, 0, 0, 4. Then if k is 1, then it's still 0. So we can. There's like, if we calculate 0 first, if the count, I don't think that will be faster. Like if the 0 count is larger than k, then we can return 0. But we should count the zeros. So I don't think that's that will be an optimization. Okay, so that's first heapify the nums, and we'll have min heap, and for each operation add the min value by 1. Okay, so let's do this like then this will, and then at the end, like return product return the product of the whole array. So time complexity will be heapify will be n, and then for each operation, well, k operations, add the min value. So for each operation, we will adding in the heap will be log n, and the product of the nums will be n as well. Okay. So let's start. We will have first heapify nums, and for every operation, since we will use every operation, because it will be larger. If we use less than k, it will not be better for the product. Okay, so add the min value by 1. Let's hipify. We'll say replace nums. If the min value will be nums 0 plus 1, and return. Oh, there's no product, so that's reduce. I think it's nums at first, or lambda. Yeah, you will have x and y. I forgot is it like this? Like this. Not sure if reduce. Let's see, Python reduce. Oh, you will put. Okay, put list at the back. So do this. Oh, I forgot the module. Then mode, I have it here. Mode is 10 with the power of 9 plus 7. Then I will do the mode. Okay, let's see. 10. Okay, the range of the number is 10, 5. Don't think it would. Or is that the product? So can I first calculate the product? Like in this so this array has like the same numbers, and how is its k? Oh, There's like no okay is I'm not sure. Let's see the solution. Okay, I think we should better do the module here so that let's see if this will be better. Okay.